Okay, Hari, I will forward the PDF, but the PDF is already uploaded on the website in the link for your particular house. So you must be used to downloading the assignments from the Iitians Hub official website. So the PDF is there already. So anyway, so question 1 from assignment 3. It's like this: two vectors were given to you and you had to just find the magnitude of A plus B. So vector E was given as 2i cap plus 2j cap. Vector B was given as I cap plus 2j cap. And we have to find magnitude of E plus B. Okay. This is very simple. You start by first finding E plus B as a vector. So you substitute E as a vector, 2i cap plus 2j cap. Substitute B as a vector, I cap plus 2j cap. Then you simplify this, so this becomes 3i cap plus 4j cap. So in component notation, the resultant sum of A plus B simply becomes 3i cap plus 4j cap. So in component notation is that, so magnitude of A plus B is the thing which the question is asking. So that is mod of this vector, which has x component 3 and y component 4. So as we studied last time, the mod of vector in component form, the magnitude is given by this formula. So that becomes 5. Okay. So this is the working and explanation of question number 1. Just complete it in case you haven't done it yet. Okay. And we'll work this out. Okay. So just note this and then go through question number 2. I'll explain that. Oh, I have some students still in the waiting room for some reason. Okay. So students who have just joined in for whatever reason, just discussing the worksheet 3, started with question number 1. So go through it and okay. So just because this is the first question, I'm starting with this. Okay, but otherwise this was a very easy question. Okay. Now in question 2, you have to take the same vector, okay, for E plus B above. Find the angle with respect to the x-axis. So this is what you have to do in the second part, which is very simple. You have to just use the formula for the angle of a vector with respect to the x-axis when it is given in component form. So this same vector E plus B we have calculated in the above question number 1. You have to now find its angle with respect to the x-axis. So just work that out also, that you're noting this down. Okay, so anybody worked out the answer for the second part? Yeah, so this is session 5 and not session 4. Yeah, this is session 5, sir, not session 4. Yeah, Itanshu, the assignment is uploaded on the Iitians Hub website. I'm just repeating for the benefit of everybody over here, so that people are continuously asking me for resending the assignment. But the fact is, the assignment is already uploaded on your website. You can access it from there directly. All your assignments from this point are going to be uploaded on the website, so that you don't have to keep downloading it from WhatsApp or whatever. So anyway, let's come to this second question of this. So E plus B we just saw was 3i cap plus 4j cap. So the angle with respect to the x-axis is such that tan theta is 4 by 3, and that means theta is 53 degrees. So if you draw the vector, it looks something like this. It's a vector of magnitude 5, but with respect to your x and y axis, first of all, both the components are positive. So you can see it lies in the first quadrant. The angle lies in the first quadrant. So this component was 4. So this is 4 over here, and this component was 3. The x component is 3, the y component is 4. So this angle we have to find out, this theta. So this is a 3, 4, 5 right angle triangle with this. So the base has 3 and the perpendicular has 5. So the angle itself is this much. Okay, so hope this is clear. Okay, so let's move on to some more questions from the assignment. So third question is, I think, pretty standard. Most of you will be able to do it. Let's come to fourth question. So third question is similar to this. Okay, so I'm not repeating it. Just like we found the angle in question 2, like that we have to find. So in question 3, there is a given vector, okay, in a diagram, and you have to find the angle with respect to x-axis. So it's a pretty straightforward question. You can work it out that way. Oh, sorry. You have to not find angle. You have to actually express the vector in component form. So that's even simpler. Okay. Express Let's come to question 4, which is have an application of all these things that we learned so far. So question 4 is like this now. It says that you have a vector E given as 12i cap plus 16j cap. Okay. And you have another vector B given as minus 8i cap plus 6j cap. Now you have to find the angle theta between A and B. Okay. Now this is a slightly more tricky type of question. So I will start by giving you a hint in this. So what you do here is, first find the individual angles . made by vector A and B with respect to the x-axis. Okay, you can even draw the vectors in the xy plane, okay, and then calculate the theta which has been asked. So just try this out. First, draw the individual vectors A and B. Okay, people. So hopefully some of you worked out this question. Yes, correct. Ananya, you got the angle correct. Tanishk, unfortunately, your quadrants are wrong, which is why you are getting the angle wrong. One of the two vectors you would have drawn in the wrong quadrant. Shikhar, correct. You got the right answer. Okay. So let's look at this. Rahil, correct. Tanishk, again, you made some calculation mistake now. It's almost correct, but yes, now it's correct, Tanish. Finally, good. Okay. So in this coordinate frame, you will see that if you draw the vector E, which was supposed to be 12 I cap plus 16 j cap, right? So you'll see the vector E looks something like this. So because it has components, oh sorry, E will be at 53 degrees. E will be more like this. So it has components 12 and 16. So when we drop this perpendicular here, this is 12 and this is 16. So this angle that E is making with respect to the x-axis, let's call this as alpha, suppose. So tan alpha is E is y component divided by E is x component. So that is 16 by 12. So that's 4 by 3. So alpha is equal to 53 degrees. Okay. But when you look at the second vector B, you realize that looks like it's here. Because the vector B was given in component form to us as having a negative x component and a positive y component of 8 and 6 respectively. So this one, this perpendicular distance is dropping is 6 and this is minus 8 over here. So for example, if you like, you can find out this angle beta, or you can find out this whole angle also, whatever. Okay. So tan beta will be 6 by 8 or 3 by 4. That means that angle is 37 degrees. Okay. So as far as the vector B is concerned, B is at 180 minus 37, okay, or 123 degrees. 143 degrees. With respect to the positive x-axis, because when you see the angle with respect to the positive x-axis, it's not this one, it is this angle over here, this angle. So this angle is how much finally? It is 143 degrees. Okay. Whereas this angle was 37. Sorry, it's 53. This other one, this one is 53. So now we want to find the angle between A and B. So that is which one in this diagram? Theta, the angle which we want to calculate, that is this angle, the angle between this and this. This is the theta we are trying to find out. So you can see that that angle is going to be 90 degrees. Because alpha and beta sum is 90, so that will also have to be 90. Okay. Therefore, theta will be 143 degrees minus 53 degrees or 90 degrees. Okay. So this is the method we have right now of finding the angle between two vectors which are given in component form. This vector and this vector A and B were given to us in component form. This is how we can calculate the angle between them when they are given in 2 dimensions in coordinate form. There is also another method which we learn later, which is called the dot product method or scalar product method, which is like somewhat faster than this to calculate the angle between two vectors. Yeah, Rahil, that's also an interesting method. So what Rahil has done is he has actually used the component notation vectors A and B to find out their sum and then found out mod A plus B from that and then use the triangle law. So you can always do that also. Yes, that's also a method of finding. Okay, so interesting that you got that tip from Yaneshwar sir. So you can always do that also. So what you people are saying is that you first find out A plus B over here. So that in this case will become 16 minus 8 I cap plus 12 plus 6 J cap. So that becomes 8 I cap plus 18 J cap, correct? Then you find mod of A plus B. So that is root of this. So root of 64 plus 324. is this. Then you use this formula that mod a plus b is root of e square plus b square plus 2ab cos theta. So in this formula you substitute this over here, okay, and in this you substitute mod a as 20 and mod b as 10, which you can find out from the vectors. So that's also a method. So that's also a kind of indirect method. Okay. So both the methods we have done, whether you are using this triangle law method or you are using this diagram method, they are somewhat indirect actually. Okay. At a later stage, we'll use the method of dot product, and you'll see it's much faster from that. Okay. Yeah, Ananya. So your answer for that was also correct. Okay. So now I'll move on to some couple of more questions from the worksheet. So that was the fourth question. Okay. Later today, make sure you download, in case you haven't, you download the worksheet from the website. I will send you the link if required on the group. Okay. But I think you must be used to downloading all the assignments now from the website. I think all subjects you are getting your assignments, notes, etc. from the website only instead of WhatsApp now. Okay. Let's come to question 5. So question 5 is like this, that it says the sum of three forces which are given by these vectors f1 is 12i cap minus 16j cap, f2 which is minus 8i cap plus 13j cap, and f3, okay, are such that when all three forces act simultaneously on a body, then the resultant force is 0. So from that you have to find the force F3 and its magnitude. In the given question we have to find just its magnitude. But so first of all, understand the language of the question. F1 and F2 are two known forces. Okay, suppose they are given to us in newtons. Okay. So that means each of the components is actually in newtons. So F2 has an x component of minus 8 newtons and a y component of plus 13 newtons, and like that F1. Now F3 is some unknown force, but the information given to us is that when all three forces act simultaneously, okay, when all three forces act simultaneously on a body, then the net force on the body is 0. The resultant force on the body is 0. So from that we have to calculate F3. So convert the language of the question into now a vector statement, that when simultaneously the resultant of three forces is 0, that means in vector algebra the language kya ho raha hai? F1 plus F2 plus F3 should be equal to 0. So how you have to solve this now is that convert this to language now, that this implies that F1 plus F2 plus F3 results in a null vector or 0. So that also implies that F3 is equal to negative of the sum of F1 plus F2. So that's it. Once you've done this, you can see it's a very easy question because F1 and F2 are already given to you. So you have to just sum them up and then put a negative sign in front of that sum. So that becomes the force F2 in vector form, and now, sorry, F3. And now you have to find its mod, which is very easy. Okay, so quickly finish off this sum. Yes, very good. Somarup, your answer is correct. No, you have to just find these two things. You have to find the force and its magnitude. You can see in the question, what has been asked is you have to just find these two things. You have to find F3 in component form and its magnitude. Yes, correct. Tanishq, your answer is correct. Shikhar, your answer is correct. Hitanshu, everybody is correct. Okay, Durgesh, correct. So you can see here that F1 plus F2 will be, when you substitute from above, 12 minus 8 I cap plus minus 16 plus 13. So remember, when you're adding vectors, the components come with their algebraic sign. That's the thing. So this is actually plus of minus 8. The x component of F2 was minus 8. So that's why there's a minus sign here. Similarly, the x component of F1 was minus 16. So that's how this minus 16 has come here. So it is, as you can see, 4 I cap minus 3 j cap. So this is F1 plus F2. Now remember, F3 is actually negative of this. Pardon, that's F3. So F3 now is negative of F1 plus F2. So F3 as vector will become minus 4 I cap plus 3 j cap. So therefore, magnitude of F3 will become 5. When you work it out, you see it become 5 newtons. Yes, Yojit, very good. The answer is correct. Okay, so that was the fifth question. So I'll just minimize this for the reference of anybody who needs it. All right, so now let's move on to the next series of questions which are all related in the same data. So again, this is comparatively easy. So in questions 6 and 7, the data that you have to use is this, that vector A is given to me, or rather vector A plus B is given, and the vector A minus B is given. And in turn, you have to find out the vectors A and B's individual magnitude. Okay. So listen to this carefully. Vector A plus B is given as 10 I cap, and vector A minus B is given as 10 root 3 j cap. Okay. So this information is given. Now what we have to find is from that magnitude of vector A and magnitude of vector B is what we want to find. Okay. So it's a very simple algebra question actually. Here we don't have to think of any geometry and stuff like that. Okay. I'll just tell you what to do here and you'll get it yourself. Okay. Consider this information given. Suppose this is, we label it as equation 1 and this is equation 2. Now just do this operation, that add equation 1 plus 2. And from that your B will cancel out. So you can find out A as a vector and then you can find out mod A. And similarly, if you subtract equation 1 and 2, you will get B as a vector. And then from that you can find out the magnitude of B. So this is the method for working out this question. Yes, that is correct, Varun. So equation 1 plus 2 actually show you that twice of vector E is 10 I cap plus 10 root 3j. So that will tell you that vector E itself is half of this whole thing. So vector E is 5 I cap plus 5 root 3j cap. And from that you can find out magnitude of vector E is 5 into 2, 10. Okay. And similarly, now you can substitute this in one of the two equations, or you can do this operation, whatever you like. Okay. So you can actually substitute this vector E back in equation 1 also and get vector E. Or you can do that operation I told you, 1 minus 2. So similarly, from that you will get 2b, equation 1 minus equation 2. You will get that as 10 I cap minus 10 root 3 j cap. You can see that the vector B becomes 5 I cap minus 5 root 3 j cap. This one. Correct. Okay. So mod B also becomes 10. So good. Most of you seem to have got this correct. Very good. Okay, now let's come to what I think is the trickiest question or set of questions in this exercise. So just give you a bit of time to go through this fully. And those who are finished, now you can start looking at question 8, 9 and 10. Question 8, 9 and 10 are based on a given set of data. Now this is a slightly trickier type of question, so I'll discuss this in detail. Okay, people, so I think this should be fairly clear now. Okay. So as I was telling you, the slightly trickier question that we have now, this series of questions, question 8, 9 and 10. Okay. They are based on this data, all three of them, that given to us is all this information that magnitude of vector E is 5 units. Okay. Then the vector C is the vector A plus 2 times some other vector B, such that C is perpendicular to E. So this is the second piece of information, okay, given to us. And the third piece of information given to us, the vector D is simply the resultant sum of A and B, such that the magnitude of vector D is also 5. So we have to find the magnitude of vector B and the angle theta between vectors A and B, and also we have to find the magnitude of the vector C. This all information has to be found out. Okay. So just understand the question first. Okay. We haven't gone through it before. Then we'll discuss what to work out in the solution. Okay. So all this language of the question is given in question 8 only, and subsequently 9 and 10 also mod B is asked and the angle between them is asked and all that. Okay. So let us see now how we will convert the given information into equations. Okay. So what we'll be doing here is, since the given information is in terms of sum of vectors A and 2B and B is equal to A plus B, we have two options. We can go with component algebra or we can go with the triangle law and the geometry. Now see, the whole thing is, it's solvable by both methods, but we have to think logically कि कौन से method में ज़्यादा आसान होगा question solve करना. So here if you observe, there are two very interesting factors given about each of these operations. When you are doing the operation that C is equal to A plus 2B, it turns out that the vector C is perpendicular to E. So any vector triangle that you will be drawing for this operation, for this one, that C is equal to A plus 2B, it will result in which type of triangle? It will result in a right angle triangle. So right angle triangles are always comparatively easier to solve. So applying triangle law for this statement is going to give me comparatively something easier because it's a well-known triangle. It's a right angle triangle. Similarly, if you see the above one, D is equal to A plus B, the magnitude of D is 5, which by the way is the same as the magnitude of A. Magnitude of A was also 5 units. So again, that's a comparatively easier triangle because two sides are equal. So it's at least an isosceles triangle. So one might think that, okay, application of geometry and triangle law is going to be the easier method of solving this question. So that is what we will start with the geometrical solution. So in the geometrical method of solving, the first triangle that I'll solve will be this one, that C is equal to A plus 2B, okay, where we know that magnitude of A is 5, and we also know that C is perpendicular to A. You know that magnitude of B is, suppose, capital B, that is unknown, and the angle between A and B is unknown, that is between A and B. So one thing we'll also understand to begin with here, that the magnitude of 2B as a vector will be how much? 2 times the magnitude of B. Okay. So if we assume that the magnitude of B is just capital B, then in this case we are adding the vector twice of B, so its magnitude will be 2B. So let's draw that triangle and understand how it looks. Okay. So suppose we assume that A is along this direction. So nothing specific is given in terms of XY axis, so we can make any assumption. So A is a vector like this of 5 units. Okay. Abhi B kahan lie karta hai, we don't know because theta is unknown. But we know about C. So C is perpendicular to this. So C has to lie something like this. C's direction has to be at 90 degrees, where C is defined as, we know, A plus 2B. Okay. So C is A plus 2B, then back in this diagram, where is the vector 2B lying? The vector 2B must be this one. So that's how we are getting the sum of A plus 2B as this. So that means the vector 2 twice of B must be this vector. This vector must be twice of B. So its magnitude is 2B, which is unknown. Okay. And the angle is making with respect to A, that will be this angle theta. This angle is. Okay. So this is my first vector triangle using the information which was given to me about the vector C. So using this above information, I have constructed this triangle. The first piece of information that was given was this. Now let's make use of this thing. let's make use of the geometry of this triangle. So this side is some unknown c. So first of all, from Pythagoras theorem, we have c square plus a's magnitude square, which is 5 square, is 2b whole square. Okay? Or we have c square plus 25 is equal to 4b square. So that is my first equation. So two unknowns, c and b, which we have to find out, will come from solving this equation with something else. Okay? And the other thing is, if this angle is theta, then this angle is, let us say, some beta or something. So we can see in the diagram that cos of beta is based upon hypotenuse, so pi by 2b. Okay, and cos theta will be minus cos beta. Why? Because theta is in second quadrant. Because theta is 180 minus beta and an obtuse angle. So theta is an obtuse angle, we know that. So cos theta, because we have to find out theta. So cos theta is 5 upon 2b. So that becomes my second equation. So two equations have been generated from this triangle. Okay, these two equations. But as you can see, there's no use in these two equations alone, because three variables. The unknown quantities for us are these three things. B is unknown, C is unknown, and theta is unknown. So two equations are not going to be enough. We're going to need a third equation also. And moreover, we also have a second piece of information given in the question, which is the information about the vector D. So we have to use that also to generate another equation. So when we do that, we'll get another equation, and using that equation along with these two, we'll get the solution of the three unknown quantities. Okay, so first make sure that this vector triangle is clear to all of you. This is the triangle which is coming from this piece of information given to us. The relationship of C with A and B. ठीक है, ये वाले इन्फो से मुझे ऐसा ट्रायंगल मिला है, और from this triangle by using hypotenuse or rather Pythagoras theorem and making use of trigonometry, I've got these two equations. Okay. Right. So now let's move on to the other piece of information that is given to me. So दूसरा information मुझे question में क्या दिया हुआ है, ये वाला information about the vector D. D is the sum of A plus B such that D also becomes 5 in magnitude. Okay. So let's make use of that information below. So the second information given is vector D is equal to the vector sum of A and B, where we know that magnitude of D and the magnitude of A are same. They are both 5 units each. Okay. And what is unknown is the magnitude of B and the angle theta. Okay. But notice one thing, that the angle theta in this question, in this above triangle, and the angle theta in the below triangle will be the same. Okay. So when we construct the vector triangle for this, A and B will now look something like this in comparison to the earlier one. Whereas if you compare this diagram with what we've done in the triangle above, triangle 1, instead of B it was 2B. So there it was like this, the same vector A, but double of this vector B. So it was like this. So this should be actually half of this in length, like this. So it should be, let's say something like this. So if you compare these two, it should be like this. So in this diagram, this should be double the length because this was 2B. But the angle is the same because they are parallel vectors. So if this is theta, this is also that theta. So that, and now the vector D in this diagram will be the resultant sum of these two, which will become like this. Okay. So D will also be a vector of magnitude 5. Okay. So now if you look at this triangle, we can see that यहाँ पे क्या हो रहा है, that we can make use of the property of isosceles triangle, that this side is equal to this side. Okay. So that means this angle, whatever it is equal to this angle. It's the same as this b bar. Okay. So now we can make use of triangle law. If D is the sum of A plus B, then the magnitude of D is equal to the magnitude of A plus B. So the root of A square plus B square plus 2AB cos theta. So magnitude of D is 5. Magnitude of A is 5. So we'll replace A with 5. So 5 square plus B square plus 10B cos theta. If you just whole square this becomes easier to handle. So 25 is equal to 25 plus B square plus 10B cos theta. This is squaring both sides. And then just get rid of the 25. So we have B square plus 10B cos theta is 0. Okay. Or we can factorize this and say, okay, B into B plus 10 cos theta is 0. So obviously B is not 0 because the vector B is not a null vector. So B cannot be 0. That means B plus 10B cos theta must be the factor which is 0. And that makes sense because earlier also we were seeing cos theta as a negative quantity. So from that we are getting that 10 cos theta is minus of B. Or we can say that cos theta expressed in terms of B is also minus B by 10. So this is going to be our third equation, third and final equation. Because now we have 3 equations for the 3 variables. So if you compare this with the first 2 equations we have got from the first triangle, you will see that we will now be able to solve this. So I'll just take you through the stages over here. So this is the equation that we are getting by using the information about the second addition thing that was given to us, that the vector D, which is the resultant of A and B, is such that its magnitude is also equal to 5 units. So making use of that, we are getting this final equation that B plus 10 cos theta is equal to 0, or B is equal to minus 10 cos theta. Okay, so note this down and now solve equation 1, 2 and 3. Okay, 1 and 2 above and equation 3 from this part only. Yeah, Somarup, so that is what you have to solve. Okay, from the above thing, cos theta is minus 5 by 2b, and from the equation 3, you are also getting cos theta is minus minus b by 10 or something like that. You know? So solve the 2. Yes, minus b by 10. So equate the 2 now. So you get the value of b from that. Okay, so minus 5 by 2b is equal to minus b by 10. Because cos theta from those 2 equations. So that equation will give you the magnitude of B. Correct. Hari, your answer is correct for mod C. And correct. Somarup, your answer is correct now. Shikhar and Somarup both have got magnitude of B correct. Good. So I'm just taking you through the equation 1 and 2 once more. So these were my equations 1 and 2. Okay, that c square plus 25 is 4b square, and cos theta is minus of, so there's a minus sign here. Let's make that correction. There's a minus sign here. It's minus cos beta, and cos beta is this much. And finally below here I've got this. Okay, so you can see that if you compare equation 2 and 3, okay, so from equation 2 and 3 we can replace cos beta, cos theta, which in case of equation 2 was minus, minus 5 by 2b. And according to this, it is minus b by 10. So you can see you get b square as 25, which generally means that b is plus minus 5, but here b will just be 5 because b is a magnitude of a vector. Or also, okay, that's done. Then cos theta, whichever one of the above two equations you use, you can substitute. So for example, if you use minus 5 by 2b, you can see it becomes minus half. Okay. So cos theta is minus half means theta is how much? It is 120 degrees. So that's the second thing we got. Okay. Because theta is obtuse, so remember we are using that. Cos theta is minus half means cos of 180 minus theta is half, which means 180 minus theta is 60, and that means that theta is 120. Okay. That's the thing. And also we have equation 1. We have c square plus 25 was equal to 4b square. So in this substitute b as 5. So you will get c square as 75 or c as 5 root 3 or magnitude of the vector c as 5 root 3 units. So this is the solving part, and that's why I told you this question is a little bit lengthy because there's quite a bit of solving involved. Okay, people, so hope this is clear. So this is up to question 10. Okay. Now the next 4 questions, 11 to 14, are again based on a common data set. Okay. And that's comparatively easier. So I'm just going to give you a hint for those questions. And you can finish them off yourself. So they are based on this diagram, which is given to us. the three different vectors are shown like this. Vector E is at an angle of 60 degrees and has a magnitude of 10 units. Vector B is also of magnitude 10 units, but this angle is 60, which means that its angle with the x-axis is actually 120. And then finally another vector C is shown to us, which is lying along the positive x direction, like this. And that is also the same magnitude 10. Okay. And then as part of the questions, various operations are asked for. So you have to do operations like what is A plus B, then what is E plus B plus C, or what is A plus B minus C, or what is A minus B. These kind of things are all the options in questions 11 to 14. Okay. So basically what you do in this question, as a hint for all the different parts 11 to 14, all of them, is that you first write ABC in component form. Okay, so step one is write vector ABC in component form, and then you can check out all these options. So what you do is convert to component form. So when you do that, you can see you should be getting this. You should be getting the vector E as 5i cap plus 5 root 3 j cap. You should be getting the vector B as minus 5i cap plus 5 root 3 j cap. And of course, the vector C is just 5i cap. Now, once you got this, you just substitute these in whatever operations are required and work out the answers from it. So substitute these here, and then you can work out whatever options. So that is how you will do these questions. Okay, pretty easy. So I'm leaving the rest of the work in these 4 questions for you. It's quite easy. Okay, so that completes this. The last question, question number 15, is very easy. So that also I'm leaving out for you people to do. Now, on the request of some people, I'll also revisit one of the questions in assignment 2, question number 14. So just hang on a second. I'm going to put up that question. Yeah, so many of you have requested me to work out question number 14. So I'm coming to that. And then we will look at the last portion of the lecture today, which is about some new principles. Okay. So from assignment 2 earlier, look at question 14. So question 14 was like this, that we are given one vector like this and one vector like this. Such that this angle is obviously 90, but this one is given to us as 30 degrees. Okay. And this is a vector P of some unknown magnitude, let's say. And this is a vector Q, let's say, of magnitude 10. Okay. So there are forces of 10 newtons and unknown magnitude P. And it is told to us that, okay, so like this, the resultant of the two, so basically this is a north, south, east, west direction. Okay. So you can see that P is a force towards 30 degrees east of north. Q is a force towards west. Okay, but it is also given to us now that the resultant of P and Q this resultant is towards north. So from that now we have to find the magnitude of P. This is the question. I'm sure all of you have tried this question. Many of you have got this also. Now you can also always do this by component method. It will be pretty easy. But at that point of time, we wanted to solve this by triangle law kind of thing. So if we solve it by triangle law method, we have to solve this vector sum. So you have to see that P plus Q kaisa hoga yahan pe. P is some force like this. Q is a force of 10 newtons, which is towards west. So this is my Q, which is of magnitude 10. This one's magnitude is unknown, but the resultant should be a force towards north. So the resultant of P and Q in this diagram will be which vector? It will be this one. So this should be towards north. This should be towards north. And we already know that the vector P is in this direction. It is 30 degrees north of east of north. Okay. This information is given to us. And the vector Q is towards west. We already know that. Okay. So now we can just solve this right angle triangle and we'll get the solution. So just solving this right angle triangle, we know that this angle will be 90. Okay. So therefore, you can see that in this diagram, you can see that cos 30 degrees should be equal to 10 by P. So P should be equal to 10 divided by root 3 by 2, or magnitude of the vector P should be 20 by root 3. So that means the magnitude of the force P, because Q was in newtons, this will also be in newtons. So it should be 20 by root 3 newtons, because magnitude of Q was. So this is the complete solution of this by triangle law method. Now, of course, you can also do it quite easily by component method. So also try this by component method now that you've learned that. But last week when we had not yet done components, this was the method by which we were supposed to solve this question. Yeah, Rahil, just to answer your question, Achha, in question 11, you are saying that one of the options. Okay, I will check out the options and if there's any correction, I'll send it to you. And coming back to your question about C and D in question number, that 8, 9, 10, that one. If you subtract those two equations, you will get the vector C minus D. So that is not going to be of any particular use. Okay. All right. So any further difficulties and things you have with Shikhar, I didn't quite get your doubt. It is Py by component method meaning? Are you talking about this particular question about this one? Yeah. So the resultant will become P's y component only. So you can do it like this only. Then you can write the vector P as some x component I cap plus some y component j cap, and the vector Q is minus 10 I cap. Okay. And also you know that because that angle is 60 with respect to the x-axis, Px will become P cos 60 and Py will become P sin 60. And then the resultant of these two should be along the y-axis only. So it should just be Py j cap. So because it is the case, you can see that Px minus 10 should be 0. And the x component of the resultant should be 0. So that is a component way of solving this, okay, which is the easier method, I told you. Okay, so now let us, good, excellent. So I think you understood, all of you understood by both the methods. So we can now move on to the next part of vectors for us. Okay. So the next part of vectors, actually we will be going back to geometrical method to understand few more theorems. Okay. So few additional theorems from the geometrical interpretation of vectors. So from the geometrical representation of vectors. So there are few additional things. So the first thing we'll see is, the first additional theorem we'll see is triangle law for difference of two vectors. Just like we have a triangle law for sum of two vectors, we also have like you can say an additional part of triangle law or a supplementary part of triangle law, which can give us the difference of two vectors. So suppose vectors A and B are like this. Okay. So given that we know the magnitudes of these vectors, and the angle theta between them. Now we want to find out A minus B. So how we can make use of geometrical method and come up with a formula for it. Just like we have a formula for A plus B, its magnitude is root of A square plus B square plus 2AB cos theta. And the angle it makes with respect to the vector A tan alpha is B sin theta upon A plus B cos theta. So like that, can we come up with a formula for the vector A minus B? So the answer to that is very simple, that you interpret A minus B, we will interpret the difference of the two vectors A minus B also as a sum operation, but it is the sum of the vector A plus the vector minus B. So we'll think of it like this. Okay. So if my vectors A and B were like this, okay, in comparison, what will the vector minus B look like? This is the vector B. Then the vector minus B, which we have to generate first, that will look like this. It's just the opposite of this. So it's this. Doesn't matter where you draw it from. You can draw it like this. You can draw it parallel to this, but the arrow should be in the opposite direction, whatever. So it's what we call an anti-parallel vector of same magnitude. Okay. So the vector minus B, whether we draw it here or here, it doesn't matter. So minus B is a vector of same magnitude as B. It's capital B. Okay. But direction opposite. To B. Okay. So that's why this vector here has the same magnitude, but its direction is opposite. Okay. And of course, remember in the original diagram, this angle here was theta. So here this angle will also be theta anyway. So now let us look at the operation. So suppose we have a new vector. Suppose we denote that with C as E minus B. So we are interpreting that as E plus of minus B. So how would this vector C look like now? So to find out C, we have to operate this. We have to first draw the vector E, whatever it was in the above diagram. And to A's head, we have to add which vector? Minus B and not B. So we have to pick up this vector, this minus B vector, and place it at the head of E. So when we place that minus B vector at the head of E, that will look like this. This will be the vector minus B. This is of magnitude B, but the angle it will make with respect to A now will become 180 minus theta. So this is the direction of A. So this angle is how much? It is 180 minus theta. Because remember, originally B was in this direction and this angle was theta. So this angle is 180 minus theta. And now in this diagram, where is our vector C? Our vector C is this one. It is A plus or minus B. So this is the difference vector C, which is A minus B. So we want to find out its magnitude. We want to find out this angle. Let's say this is beta. So we want to find out all these things. So we want to find out magnitude of C, and we want to find out the angle beta. So now we use the statement of triangle law only, but the only difference is the two vectors we are adding, their magnitudes are A and B, but the angle between them is how much? 180 minus theta. So using triangle law, so since C is equal to E plus of the vector minus B, so therefore mod of C is magnitude of the resultant of these two vectors. So that according to the statement of triangle law is magnitude of A square plus magnitude of minus B square plus 2 times the magnitude of A into the magnitude of minus B into cos of the angle between them. Now remember, the angle between these two vectors is not theta. The angle is 180 minus theta. Okay. So this is the important point over here. This is the angle between A and minus B. Okay. And also mod A is E. Mod of minus B is equal to mod of B, which is okay. So substituting these things over here. So we get magnitude of C is becoming, just replace everything. Okay, so A square plus B square plus 2AB into cos 180 minus theta, which is minus cos theta. So here we are making use of the fact that cos of 180 minus theta is nothing but minus cos theta. So from that we get this important formula. The magnitude of A minus B is root of A square plus B square minus 2AB cos theta. Okay. So this is like the supplementary form of triangle law. This is the secondary or supplementary statement of triangle law. This is triangle law for difference of two vectors. Okay. Whereas earlier you had seen for the sum of the two vectors, you have the original form of triangle law, which is this. Okay, so alright, so I will just leave you to understand this whole derivation once. So you can start from above itself. This is the new operation we are doing, triangle law for the difference of two vectors. So we are interpreting the difference as the sum of the vector A with the vector minus B. Okay, that's how we are interpreting this. Yes, basically it is just that, Ritika. You're correct. Okay. And unfortunately, I don't have the name of the person who is asking this question, but somebody has asked whether this is the same as cosine rule. Yes, when we interpret in terms of just trigonometry of a triangle which has sides A, B, and C, this gets converted to cosine rule. That the side C has a magnitude or has a length of root of A square plus B square minus 2AB cos theta, where theta is the angle between A and B. So this actually, this vector triangle is the same thing as your, triangle. Yeah, Rishi. Okay. So in trigonometry, when we apply this to any arbitrary triangle instead of a particular vector triangle, this is referred to as the cosine rule. Okay. So this is how we have done the calculation now of the difference of these two. Okay. Now the second part is, of course, we have to find the angle beta also. Okay, so we are coming to that. Okay. So just like we have used this part over here, we can also see that tan of beta here will become minus b mod the sine into the angle between them, which is 180 minus theta, divided by mod of a plus mod of minus b into cos of that same angle. Okay. Remember, sine of 180 minus theta is equal to sine theta only, because sine is positive in the second quadrant. So this becomes b sine theta, whereas cos of 180 minus theta we just saw is minus cos theta. So this becomes about the angle. So now final result, we can also add the formula of the angle. So now final result here, we will just also additionally put this, that the angle beta there is such that tan beta is b sine theta upon e minus b cos theta. So this is about the magnitude and this is about the direction. So that is how we interpret this. Okay. So let's do a quick example based on this. Vector E has a magnitude of, let us say, 10 units, and vector B, or wait a minute, let's and vector B has a magnitude of 50 root 2 units, and the angle between them, theta, is in the first case 45 degrees. So you find mod of E minus B. Okay. The second case, let's take the angle between them as 135 degrees, and again we have to find the mod of A minus B. So just start by working out this question. So just make use of the above formula for the difference of two vectors. So I'll just minimize this so that you can refer to that formula also. Okay, yeah, this formula now. Okay. And use it for the two separate parts. One part you have to take theta as 135 and one part as 45. For both the cases, the magnitudes are 50 and 50 root 2 respectively. Yeah, so most people have got this correct in the chat replies. So just quickly discuss for the first part, mod of A minus B by this formula. So that becomes 50 square plus 50 root 2 whole square minus 2 into 50 into 50 root 2 into cos 45, which you know is 1 by root 2. So you can just take 50 common outside the square root. We have 1 plus 2 minus 2 into root 2 into 1 by root. Okay. So we have this. This becomes our answer. Okay. And if you are referring to the diagram, how it will look like, the vector sum diagram here, it will look something like this. Sorry, this will just be 50. E is of magnitude 50. The angle theta between A and B is 45 degrees. So this angle here is 45 degrees, and minus B has a magnitude of 50. So the difference of A and B will become this vector here. So this vector is C, let's say. Okay. This will also have a magnitude of 50. This angle will in fact become 90. So here C is E minus B. So this and this actually correspond to each other. Okay, then we have the second part where we are taking the angle between them as 135 degrees. But obviously mod A and mod B are still the same. Okay. So in this case, cos theta, which is cos 135 degrees, will be minus cos 45 degrees. So it will be minus 1 by root. So let's substitute this over here. So you can see that we'll get 50 square plus 50 root 2 square minus 2 into 50 into 50 root 2 into minus 1 by root 2. This will be like this. When we substitute this, we get this. So this time, we take 50 common. It is 1 plus 2 plus of this, because the minus minus sign cancels. It becomes 50 root 5. This is the magnitude of A minus B. And you can make the vector triangle and verify this also, which I'll do in a moment. But first, just note this down. Okay, so when I make the vector triangle, it will make more sense to you why it is 50 root 5 in the second place. Okay, so let's look at the vector diagram and understand it from there. So here, if vector E is like this, of magnitude 50, in comparison, what does vector B look like? It's at 135 degrees to A. So B looks like this. But remember, we are not adding A plus B. We are doing subtraction of A and B. So this angle theta is 135. So next, when we operate the difference of the two vectors, the difference triangle will look like this. Taking the vector A, and to that you are going to add the vector minus B. So you're going to take negative of that above vector. So that vector will lie here. This is the vector minus B. Its magnitude is the same as the vector B, so 50 root 2. But the angle that this one is making, this exterior angle here, will be 45 degrees. Okay. Because this angle will be 135. Okay. And that is why now the difference of A minus B, which is this one, will be coming like this. this one will have a magnitude of 50 root 5. So this diagram will correspondingly make sense to the value that we got. Okay? It will make even more sense if you now understand it this way, that this was vector A, this was vector minus B, and this is the vector C you're trying to calculate. Just use different colors, don't mind that. Now, if you just extend this line and drop a perpendicular here, you can see that this was 50 root 2 and this angle was 45. So this side becomes 50. This side also becomes 50. And this side is already 50. So you can use simple trigonometry here also. You can see that this side is 50, this side is 100, the sum of these two. That's why mod C is coming out to be 50 root 5. Okay, however, we don't need to do all this geometrical drawing and all that because we already know the formula. We have to just substitute the values correctly in the formula. That is the whole point of it. Okay. So this was one additional theorem. Okay, now the next thing we'll see is that the next thing we'll understand is in the additional theorems, we will see the combined form of the two triangle laws. That is triangle of a sum and difference. Okay. And this combined form becomes what we call the parallelogram law for vectors. Okay. So what we do is we construct what is called a vector parallelogram. And in that parallelogram, we'll see that the two diagonals, one of the diagonals will represent the sum of the two vectors and the other will represent the difference. Okay. So the method here is given vectors A and B, okay, we construct a parallelogram with adjacent sides represented by A and B. Okay. And now in this parallelogram, the diagonals represent the sum or the difference. Rahil, which question you are referring to? The second part I had taken the angle as 135, no beta? See, the previous question, beta, this was the second part of the question. In the first part, we had taken the angle as 45. Okay. Just a moment, people. I have to clear Rahil's doubt. So this part we had already done. Theta is 45. इसमें तो answer आ गया था. In this part's answer, it was 50. But this part's answer, it was not 50. This part's answer, the answer is 50 root 2. Sorry, 50 root 5 for the magnitude of A minus B. And that is what I explained in the last part, how it is coming. In this part, the answer for A minus B is magnitude was 50. Okay. So the solution of the first part was this triangle, or this one. Okay. But in the second part, where the angle changes to 135, so the vectors A and B look like this here. They don't look like what they look like. So by the formula method, this is the solution. By the geometry method, this is the solution. But both ways, you can see it is 50 root 5. Okay. So there are two different parts. Okay, now coming back to this. So you will see that we can combine
the two triangle laws into one single law, which is called the parallelogram law of vector addition and vector difference, both in the same thing. So in the parallelogram law, these are the steps that we do. First, given two vectors A and B, we construct a parallelogram with the sides, with the adjacent sides as A and B. And then we will see immediately once we construct that parallelogram that the diagonals actually represent, one of the diagonals represent the sum and one of the diagonals represent the difference. So let's understand how this is done. So suppose these two vectors A and B are given to us. These are our given vectors E and B. Okay. And the angle between them is theta. So magnitude of A is known, magnitude of B is known, theta is known. So step one, okay, construct the vector parallelogram with the given vectors E and B. So to construct the vector parallelogram, this is what we do. We draw first both the vectors E and B from a common origin. Okay. So instead of drawing them one after the other or head to tail, we draw them from a common origin. So this is vector E and this is vector B. And this is the angle theta between them. And then to make a vector parallelogram, what we do is we take two more vectors E and B, which are identical, and we just place them here only. So we place them like this. So this also represents the same vectors. Okay. So that's what we've done. We have constructed a parallelogram such that the adjacent sides of the parallelogram are E and B, are the given vectors E and B. Okay. So this is my step one. Now step two, we'll find E plus B within this, and we'll find E minus B within this by observing the diagonals. So this was the origin from which I've drawn the vectors E and B. This angle is theta. So that means here this angle is also theta. Okay. And these are sides of magnitude A and B. So you can see that in my parallelogram, this particular diagonal here from the origin to the opposite side, this now represents the sum of A and B. So this is E plus B. And if this angle is alpha, then we have the formula from the triangle law, which will be the same. Okay. So we have this, and likewise we'll see that the other diagonal of the parallelogram, which will be this one, that will actually represent the difference. Okay, but first make sure you understand this properly. So given two vectors E and B, step one is we construct a parallelogram such that the adjacent sides of the parallelogram are the vectors A and B. So make sure you understand step one first. Then we'll come to step two, in which we'll see first the sum of the two vectors and later the difference also. Okay, that will become very clear to you over time, that which one is the sum and which one is the difference. I'll give you a method of working around. Okay. So step 1, I hope, is clear to all of you. How to construct the vector parallelogram. And then step 2, from that, so when you were constructing the vector parallelogram, first you drew vector A and B from some common origin. So the diagonal which is from the common origin to the opposite side, that becomes the sum. So here we'll recognize it like this, that the primary diagonal which is from the common origin for the two vectors O to opposite vertex, that always represents the sum. Okay. Whereas next step we'll see the secondary diagonal which is from the head of B to the head of A, this one, that will represent the difference. Okay, so I hope the sum step is clear to all of you. Just to save a bit of time, let me pick this up. See if I can redraw it over here. So now in that same parallelogram, you can see that we can now do this operation. Just a moment. Okay. Right. So okay, now coming back to the same one, in this, for a moment, forget about this one and this one. Just look at this vector E. Just a moment, people. Just having a bit of software issues here. Just give me a minute, guys. I need to restart this program. Okay. Okay, so we should be good now. Right. So now, for the moment, just concentrate on these two vectors E, and instead of the vector pointing in this direction, if I made this vector pointing in the opposite direction, like this now. So this vector would represent which one? It would represent minus B. Okay. So if this vector is B on this side, you can see, if this vector is B, then on this side, this opposite vector is minus B. Okay. So now concentrate on these two vectors. This one here is E. Okay. And this one here is minus B. Okay. So forget about this vector for the moment. So the resultant of A and minus B is basically the difference. No? So this is becoming the difference. This vector is becoming now E minus B. And this angle is beta. So we'll have the same formula for this, which we had in the second part of triangle law. Yes, that magnitude of A minus B is root of A square plus B square minus 2AB cos theta, and tan beta is equal to is B sin theta upon A minus B cos theta. So the same formula as we had before, but so you can see in this triangle, what is happening is that the secondary diagonal, I mean in this parallelogram, the secondary diagonal, which is from the head of B to the head of E, that represents the difference. So the so-called secondary diagonal, okay, that is the diagonal pointing from the head of vector B to the head of vector E, that represents the difference. Okay, so that is the complete explanation of parallelogram law or the vector parallelogram. And you can see that in the same parallelogram, the primary diagonal from the origin to the opposite side represents the sum, and the secondary diagonal, which is from the head of B to the head of A, that represents the difference. And the formula for the primary diagonal or the sum is this one, and the formula for the secondary diagonal or the sum is this. Okay, yeah, we have completed the lecture anyway. It's well past 2. Okay, fortunately we had a delayed start today, so this is the portion for the session today, 5th lecture of vectors. Okay, I'll be sending you another worksheet. The worksheet will be uploaded along with the whiteboard notes in the website, and I will send you people a link because you seem to be having some difficulty, some of you, with getting it from the website. But you will also find the previous 3 assignments and the whiteboard notes. Everything will be there on the website uploaded. So anytime you lose it and you have to re-download it, you can always do it from the website also, along with this lecture also. Okay, so that's it, people, for today's lecture. Okay, make sure you revise this and discuss any doubts that you have with me. Yeah, just to answer your last doubt over there, this angle here is 180 minus theta, because this angle will be 180 minus theta, because this angle is theta, so you can see that angle. Just like over here, the angle between A and B is theta. Like that, over here, the angle between A and minus B is 180 minus theta. So you can see that this triangle is basically the second part of the triangle law that we had drawn earlier, whereas this triangle is the sum wala triangle. So that's how the parallelogram is actually the combination of the 2 triangles. Within the same diagram, within the same parallelogram, you have the sum triangle also, and you have the difference triangle also. So it is nothing new actually. It is the same as the statement of the 2 triangle laws, but you can just say it's a form where the 2 statements are combined into one package or into one single geometrical figure, which is the parallelogram. Instead of 2 separate geometrical figures within the same geometrical figure, which is the vector parallelogram. If this is the vector E and this is the vector B, so we can see within this we have the sum also, and within this we have the difference also. It's as simple as that. So it's just to make life easier so that we can compare the sum and the difference within the same geometrical shape. All right, people. So that's it for today, and all the best, and stay safe with the lockdown and everything. I don't know how many of you are in red zones, green zones, and yellow zones respectively. Okay, but whatever it is, continue to be safe and observe all the precautions. Okay, and all the best. Continue working hard with your studies, and of course with assignments and things like that. Okay, that's it for today's class, people.